Space occupies three dimensions. But if you were to fly high above the sun and look down on the orbits of the planets, you would see that the orbits exist in only two dimensions. That two dimensional area is called the orbital plane. Planets orbit in a shapes called ellipses. On these images, the sun is represented by a yellow dot, and the center of the orbit is represented by a black dot. Now, in the first two images, the yellow dot and the black dot are so close together that they completely or partially overlap. The first three images are representative of real orbits. The rest of the images are too elongated, or the sun is in the wrong place for these to actually be orbits. The second image is the orbit of the Earth. The third image is the orbit of Mercury. You can see that the orbit of Mercury, or in the orbit of Mercury, the sun is farther from the center of the orbit than it is in the Earth. In fact, Earth's orbit is very close to being a circle. Mercury's orbit is more eccentric or more elongated. Quite often, when we see representations of Earth's orbit, they look like image A. Image A is actually a representation, a diagram representing Earth's seasons. It's not wrong, but what the artist has chosen to do in this image is to tip the orbit partially on its side. So we're looking at it at an angle. We're not looking at it flat on. And that's why it looks more elongated than it really is. Now, there are other problems with this image. The scales are very wrong. Like the Earth is much too big. The sun and the I guess even the sun is too big. Those are choices that were made to show the images. The Earth should actually be much farther away from the sun. But the point is that in drawing A, the orbital plane is tipped partially on its side, so we're looking at it from an angle. If we were to look at it flat on, normal to the orbital plane, then the orbit of Earth would look very much like image C. And you can see the sun is very, very close to the center of Earth's orbit, but it's not quite at the center. Image B is an exaggerated image that is much more elongated, much more eccentric than the orbits of planets in our solar system. Sometimes you may actually see the orbits represented this way in a very flattened out ellipse, but this is also not accurate. Most orbits come very close to being circles. And in fact, in the last slide, we saw that Mercury, which is one of the more eccentric orbits, one of the most eccentric orbits, is really not that far off from circular. Astronomers worked for many, many years before they finally figured out how the planets orbit the sun. If you think about it, it's really hard to look at the motion of the planets from the Earth and figure out that they all move around the sun, and they all move around the sun in elliptical patterns. And there were a lot of different theories about how that motion happened. Most of them were based on circles. Johannes Kepler was the astronomer who finally figured out that the planets move around the sun in ellipses. All the planets orbit the sun in ellipses. He did this by studying Mars, by using very careful observations of Mars and its positions in the sky. And he determined the orbit of Mars and then could determine the orbits of the other planets from there. Now, this wasn't his first model. He worked on this for many years, and he had many more attempts to explain the motion of planets, and some of them were very complicated. And, but but it turned out that the ellipse best models the shapes of the planets and could be used. The ellipse could be used to make accurate predictions about other planets' motion. And we now know, because we're able to observe the motion of objects in different ways, we're now able to confirm that the elliptical model of planetary orbits is the correct one.